For photographers, like everyone else, color is very important. When we look around, we see the world in many colors. This is because of how our eyes are built. Roses are red and violets are blue, but we are only capable of seeing different colors because we have specialized cells in our eyes called cones. Without them, these flowers, all photos, everything we see in the world would be in grayscale. The resolution of digital cameras is measured in megapixels. This means that a camera has many millions of pixels that each work like the cones in human eyes. Back in the studio, the photographer uses computer software to make changes to the photos she's taken. Sometimes she wants the computer to tell her what color a part of her picture is. The process, called color detection, figures out the color of each pixel in the picture with a specific code. Computers use the RGB color model. The name of the model comes from the initials of the three primary colors: red, green, and blue. This is an additive model in which these colors are mixed together in various ways to create any shade humans are able to see. Adding red to green makes yellow. Adding red to blue makes magenta. Adding green to blue makes cyan. Adding all three primary colors together makes white. No color of any kind equals black. In nature, this is shown best in a rainbow, which breaks up the white light into all colors we can see. So when a computer is in the process of detecting colors, it goes about it in these steps. Based on the intensity of the reflection of each color by the surface, a color sensor calculates the mixture of the three colors to get a number. This number represents a color that is already saved in the color sensor's board. The color sensor has two parts: the emitter, which is the LED, light-emitting diodes of the three primary colors, and a receiver, which is a light intensity sensor. So the sensor determines if the pixel has light on it. Then, using a scale from 0 to 255, it works out the amount of each colored light falling on each sensor. The final result is given as three numbers, ranging from 0 to 255, or written as hexadecimal code. The color sensor needs to be placed directly in front of the surface it needs to color detect. Otherwise, the result won't be accurate. It measures the intensity of the reflected light using the light intensity sensor. Unfortunately, the color sensor can't detect shapes, only colors and light. Most industrial robots do not see. They have sensors that provide just enough information to the robot so it can do its job. So a robot can still be extremely useful without vision. More complex camera-like eyes have been developed for robots as more and more jobs demand it. These allow a computer or robot to recognize color for tasks like quality control, or even distinguish uniquely colored objects like warning signals. However, our eyes are still more complex than any camera we know today. But color detection gives robots the ability to react to their environment. They are becoming more like us.